Today we're taking a look at section 5-3 on binomial probability distributions. As we talked about in our previous section, we are discussing a probability distribution. And in particular, we are talking about a discrete probability distribution. So we are talking about a case where we will have a random variable that will have a finite number of values. So as we look at these discrete probability distributions, we have a special type that's called the binomial probability distribution. And I have listed here what the requirements are for this particular probability distribution. We have to have a fixed number of trials. The trials have to be independent, which means the outcome of one trial in no way affects the outcome of another trial. Each trial must have two possible outcomes, and we label those S for success or F for failure. The probability for each trial must remain constant. Now we have some notation. We use N to represent the total number of trials. X represents the number of successes in the N trials. P indicates the probability of success. Q indicates the probability of failure. And just a reminder, we know that P plus Q should always equal 1. And P of X is the way we say the probability of exactly X successes in N trials. Okay, so what we want to make sure of as we work on the problems in this section, that we want to make sure that X and P refer to the same category, which is being designated as a success. And it might be something like someone coming down with a disease, so don't think it's always something positive. It's just labeled a success because it's what we're looking for. Second of all, when sampling without replacement, the event can be treated as if it were independent if the sample size is no more than 5% of the population size. So that's something we talked about before, and we want to remember that that's the case here. Okay, so the question is, how do we identify a binomial probability distribution? Well, what I've done is I've listed, I believe it's 5 of these, 5 examples, and I want you to say either yes, it's binomial, or no, it's not binomial. If it's not binomial, identify which of the 4 items that we have that are requirements for binomial probability distribution, which of the 4 is not being met. So you have 5 cases here, 5 different examples, and so read through each of the examples and label it as yes, meaning it's a binomial probability distribution, or no, it's not a binomial probability distribution. If your answer is no, indicate why you're answering no. So I would say pause the recording right now and read through these, give your answer, and when you have the answers, then start the recording again so we can go over these. Okay, I'm assuming that since you've restarted the recording that you have come up with answers for numbers 1 through 5. So number 1, we have survey a class of 30 students to determine how many have A's, how many have B's, how many have C's, how many have D's, and how many are failing. And my answer to that is no, it's not that a probability distribution, and the reason we have more than 2 outcomes. So with a probability distribution, we want to make sure we only have 2 possible outcomes. One we designate as success, the other we designate as failure. And here we are talking about A's, B's, C's, D's, and F's, so we have 5 outcomes, and certainly that's more than 2. All right, number 2, we survey a class of 30 students to determine how many failed the last test. Okay, that would be a probability distribution. We might actually survey several classes of 30 students to figure out to record how many failed the last test. And so we do have 2 outcomes. Either they failed it or they did not fail it. So that would be a binomial case. All right, number 3, survey 50 voters leaving a precinct in California to see if they voted for Arnold Schwarzenegger for governor. So again, in this case, we have 2 outcomes. When they answer, they either say yes, they voted for him, or no, they did not. So it would be a probability distribution. As you can see, we seem to be primarily looking at that last requirement, or the requirement that there's only 2 possible outcomes. In a class of 100 students, you check 5 random tests to see how many missed question number 2. So in this case, again, either they missed question number 2 or they didn't. And so you could have your random variable could go from 0 to 5, and it would be an answer of yes. In a class of 100 students, you check 5 random tests to see how many answered A, how many answered B, how many answered C, and how many answered D to question number 6 on the test. This one, again, would not be random variable, not be binomial, because of the fact, again, we have actually 4 possible outcomes, and we're looking only for 2 possible outcomes. So we've got 2 more than what we need in this particular case. Now, in working with probability distributions, and in particular with binomial this time, we have several ways we can calculate the binomial probabilities. One is using table A1 in the textbook, and we'll look at some examples of that in our sample problems. A second way is to use a formula, and you'll notice the combinations are used in this formula. So you have P of X, and I think I may actually give the formula in a different format from the book. Yeah, the book gives the factorial format for this part. I just go ahead and use the combination, since I figure most students are going to be using calculator. And it's combinations, that's kind of hard for me to read at least, of n objects taken x at a time, probability of success raised to the x power, probability of failure raised to the n minus x power. So in case you can't read that. So some cases are not covered in the table, so we're forced to do either 2, 3, or 4. The formula works in every case, and then we have our TI-8384 calculator, which has some benefits and some problems. And StatDisk is also useful in some specific cases. And what I'm going to do in the sample problems is I'm going to do some by table A1, some by the formula, some using the TI-8384, and some using StatDisk. And in terms of what I do, it depends on the problem. It's a problem that can be done quickly with the table. That's really the fastest way to do it. In some cases, the formula is the only thing I can do. That's kind of my last choice. TI-8384 is fairly easy to do, so fairly often I choose that. There are some special cases that I prefer StatDisk, and I'll explain why when we get to those particular problems. So we have 4 different methods for calculating binomial probabilities. So we'll go over those in the sample problems.